Okay, this is going to be a video on functions, self-inverse. Now, self-inverse is an interesting type of functions question. I will introduce what we all know. We all know that if we pass through a function with its inverse, we are going to get back x, which is an interesting identity over here. In fact, I can go further to say that if the function were to look something like, maybe something like this, and then what's going to happen is the inverse is going to look something like this, and it's going to intersect on the line y equals to x. Okay, so this is what we know over here. That's an identity. There are some functions, special cases and very rare, that you achieve the same result by passing through itself, not the inverse. You don't require to pass through the inverse. You just pass through itself and you get x. So the function itself almost acts like an inverse, sort of, which seems very strange. So therefore we call it self-inverse. It's just a special case again. Special case. So let's see. I would like to explore if I can create a self-inverse function from scratch. Okay, suppose. Okay, I would like to see if I can do a self-inverse. So I'll pass this through. Okay, it seems over here that I have a quadratic equation. I could use quadratic formula to solve, but before I commit to that, I would just like to know that the b squared minus 4ac actually exists. In this case, if I want a solution, then it should exist. My b squared 4ac. I need this to greater or equals to 0. I want a real root, at least one real root. Okay, so let me go ahead and solve it. Is this helpful? I mean, I can write this if it helps. Okay, so here we have an equation that we find it hard to reduce until I can think of an additional equation to sub it in. It almost seems like we're banging our heads into a wall. Let me see. Yeah, and we can't really factorize. Could we factorize this out? A, B? We could do a B here. Okay, so instead of writing this line, I could go and write this. If it is of any help. Okay, so this is an interesting case here. So what I'm going to do is, in this case, since I just want a possible value, I suppose I can take the liberty of substituting in values that I so please, as long as it satisfies this inequality over here. So I don't want to know the entire range of A and B because that seems a little bit difficult, but I can at least find one or two possible cases. And over here, when I see a plus 1, I'm thinking to myself, could I make this thing become 0? Because if this is 0, then the whole thing collapses into 0. 0 is indeed smaller than 1/4. So this is my guess. A is -1, and this will be 0. Yep, everything else. If A is -1, then B can be anything. And okay, anything, real number. Yes, so this will work. What is another instance? Well, if I let B be 0, or in fact, if A is 0, that would suffice as well. B can be anything. Let's check. B can be 0, and A can be anything. Okay, so over here I have 3 cases. Very interesting. So I can create 3 formulas that are self-inverse. So let me substitute in the values and see what we get. Plus B. So let me just maybe 5. A is 0. Now, I see that I have to reject this. Why is that the case? If A is 0, fx is just B. What kind of function is that? Right? No, right? And in fact, if I self-inverse it will not be a self-inverse function. So I have to reject that. Okay, now let me check the last one. B equals to 0 over here. So we are saying that we can choose any A, but no, if I pass this in, it will be 4x. That will not get us what we want. No, then this one I reject as well. Okay, perhaps there are further considerations that I have missed out, but let's try the first one. Let's put it to the test here. Okay, let me try. So this is a self-inverse. Okay, so for a linear function, you can say we have kind of cracked the code. We have created one function that is self-inverse, and the function looks like this. B is a real number. Okay, this will give you a self-inverse. Okay, so of course with other functions, you probably are able to find interesting self-inverse functions. You can do that in your free time if you find this fun.